This is TechCrunch.
General Fusion announced on Tuesday that it had successfully created plasma, a superheated fourth state of matter required for fusion, inside a prototype reactor. The milestone marks the beginning of a 93-week quest to prove that the outfit's steampunk approach to fusion power remains a viable contender. The reactor, called Lawson Machine 26, LM26, is General Fusion's latest iteration in a string of devices that have tested various parts of its unique approach. The company assembled LM26 in just 16 months, and it hopes to hit break-even sometime in 2026. General Fusion is one of the oldest fusion companies still operating. Founded in 2002, it has raised $440 million to date, according to PitchBook. Over that time, it has seen competitors rise and fall, and, like the fusion industry writ large, it has failed to meet break-even promises, including one made over 20 years ago. In fusion power, there are 2 points at which a reaction is set to break even. The one most people think of is called commercial break-even. That's when a fusion reaction produces more power than the entire facility consumes, allowing the power plant to put electricity on the grid. No one has reached this milestone yet. The other is known as scientific break-even. In this case, the fusion reaction needs to produce at least as much power as was delivered directly to the fuel. Scientific break-even only looks within the boundaries of the experimental system, ignoring the rest of the facility. Still, it's an important milestone for any fusion attempt. So far, only the U.S. Department of Energy's National Ignition Facility has reached it. General Fusion's approach to fusion power differs significantly from other startups. Called magnetized target fusion, MTF, it's similar in some regards to inertial confinement, the technique the National Ignition Facility used in late 2022 to prove that fusion reactions could generate more power than was required to start them. But where the National Ignition Facility uses lasers to compress a fuel pellet, General Fusion's MTF reactor design relies on steam-driven pistons. Inside the chamber, deuterium-tritium fuel is zapped with a bit of electricity to generate a magnetic field, which helps keep the plasma contained. The pistons then drive a liquid lithium wall inward on the plasma, compressing it. As the fuel is compressed, its temperature rises until it sparks a fusion reaction. The reaction then heats the liquid lithium, which the company plans to circulate through a heat exchanger to create steam and spin a generator. MTF emerged in the 1970s from the U.S. Naval Research Laboratory, where researchers were developing concepts for compact fusion reactors. Those efforts didn't bear fruit. General Fusion says that's because the pistons compressing the liquid liner weren't controlled precisely enough, and that modern computers now provide a better chance at executing the complex choreography. Whatever LM26 accomplishes, General Fusion still has more work to do. The device doesn't have the liquid lithium wall, instead relying on solid lithium compressed by electromagnets. That limits the number of test runs the company can take since it takes longer to reset the device. The company has made progress on a prototype of the liquid wall, performing over 1,000 tests to see how it holds up over time, but integrating everything will still be a monumental engineering challenge. Flipping the switch on LM26 is nonetheless a significant step for a company that is now racing to deliver a power plant alongside a host of newcomers with their own deep pocketbooks and aggressive timelines.